All right, I presume we're live. So let's get started. So hello everyone. I'm very happy to have the honor to present one of the two first workshops of Tag North this year. And we're going to be talking about blockchain. First of all, I'm Zvezdan. I'm a student at UCL, University College London, and also at Waterloo as an exchange student this year. And you can contact me on this address. And today we're going to be talking about blockchain. Now it's going to be very theoretical. And for the first half, we're going to be doing it very simply, slow and steadily with a lot of examples and different sizes of things. That's the most important one. If you get it, amazing. Second half, more details, slightly more technical. If you don't get it, it's all right. It's the less important part, but still a very fun one if you want to get into it. But first of all, let's talk about my background and why am I qualified to talk about this. So I've spent some time the last few years working on research in blockchain. I've designed some blockchain protocols, for example, for distributed machine learning. I'm also currently working on a smart contract security project at UCL. So we're trying to essentially increase the security of Ethereum smart contracts. Okay, so let's talk about blockchain. And before we actually introduce the whole topic, I really want to stress the importance of understanding what blockchain is and the huge responsibility that you take as a potential blockchain developer or a potential user of a blockchain software, and also how impossibly easy it might be for you to actually slip and mess something up just a tiny bit that will just lose some people hundreds of millions of dollars. Not so fun, innit? So let's talk about Ethereum. That's the second biggest cryptocurrency. And they were running a crowdfunding campaign back in 2016. So this campaign essentially allowed outside investors to put money in something called the DAO, and they get to have voting rights as to how this whole collected money is being spent to develop the future of that cryptocurrency. All fine and well. And at the time, this was also the largest crowdfunding campaign in history. Pretty good. Except that there was a bug in the code. And fun fact, the DAO was written in the programming language, or in a new programming language called Solidity, which was designed by the creators of Ethereum. And the same creators wrote the code of the DAO. So, basically the biggest experts you could probably figure out on this language. And there was a bug in it. And then that allowed someone to completely drain all of its hundreds of millions of dollars at the time. At current rates, this would be like some billions. So what I'm saying is that was a huge catastrophe. It created lots of ripples in the blockchain industry. The way it got fixed was quite ugly and created a lot of conflict and division. What I'm trying to say is trying to understand blockchain is very fundamental, very important, and very difficult. And never think that you actually understand enough and that it's all right, you can just, do your thing. You should always be vigilant and, think on your toes. With that said, like I mentioned, this workshop will be very theoretical, and I really want you to pay attention a lot. I guess you probably know already why. And this is also a beautiful introduction to my workshop tomorrow at the same time, which is going to be a lot more practical, and we're going to be actually coding smart contracts in Ethereum. So that's the easiest way that you can start writing blockchain applications for this. Now, you don't necessarily need to understand everything here today to attend the workshop tomorrow. That's all right. But they complement each other a lot. With that said, let's get going. I'll be taking a few breaks throughout the whole talk because I'll be talking too much. I do that, okay? But I'll try not to. And where you're going to click around some websites with me, and I'll give you some minutes to do that for yourself as well. And then we're going to continue. Okay. So let's talk about how people use applications or software in general. So if you're using, for example, a chat app, that app usually communicates to a server. So if you're trying to send a message, you're sending that message to a server. It's quite centralized, but it's the usual way things are done. It's the usual way governments work. It's the usual way the banking system works. All this is quite centralized. But let's ask some basic questions here. So if we've got this server scenario with a chat app, the server completely determines if your message will be accepted. So if you even have the right to send a message or to use a service or to send, to reach a particular contact, the server completely determines whether it decides to censor your message, delete some parts of it, modify it, or do whatever it wants with it. And it also determines who can access your message in the future, assuming it's not completely encrypted. So it's quite centralized, and it has a pretty significant role in how things are run. So meaning you must trust the owner of the server. And yeah, usually these owners behave well when everybody's happy, but not always. And in some critical applications, that trust is very, very, let's say, unhealthy or unnecessary. Okay. So what does a blockchain do? Well, let's use a very funny example. Let's say blockchain is just a pile of data where everyone in the world has the right to add more data to this pile of data. So you can say it's a chain of data. So like just data on top of each other. So it's just like a list of data, and it has a particular order. So it's by time. And every computer can just plug more data onto it. Completely oversimplified. But let's start with this, okay? Now, where's the security coming from? So why would this ever be, different from a centralized thing? What's this pile of data? Where is it, right? Is it on some server again? Because if that's true, then, where's the security coming from? Okay, now let's say instead of having one computer, we've got 4 or a few more. And let's say every computer stores locally on their hard drive a copy of that pile of data. Okay, and everybody has the same data right now, the same pile of data, okay? And let's say these computers are running a very simple program that allows them to communicate with each other. Okay, all of them are running the same very, very basic program. That says one thing. If one computer comes up and says, hey guys, I want to add some data to the pile of data, every other computer will be like, sure, mate, and we're gonna add it. Okay, so what just happened? Essentially, everyone has the right to announce and say, hey, I want to add this thing on top of the blockchain. And everyone else is like, receives it and is like, sure. And then they add it to their local copy of the blockchain. What happens now is we're in the same situation as we started with, that this copy of the blockchain is everywhere and it's synchronized, meaning it's the same everywhere, right? Except that it has my data on it. And if you think about it, blockchain has a lot more bells and whistles into it because there are many problems as to how to actually apply it, how to actually make this happen. But I would claim that this is a very, very fundamental way of understanding the value of blockchain, because this is actually the thing that's giving it security. Is that because this blockchain is being replicated on so many computers at the same time, nobody in the world could actually tell me that I didn't add something to the blockchain at some time. Like if I announced, hey, I want to add this pile of data to everyone else's blockchain, to the blockchain. Yeah, because the blockchain is literally everywhere on so many computers, and because it was added at the same time on so many computers, nobody in the world could tell me, this didn't happen. No, of course it happened, and it's common sense because you can know what's up. And that's very fundamental, because just from this little principle, you can actually create very powerful tools, very powerful applications, like very powerful applications in real life. Just with this basic principle, you can create a currency, you can send money, you can create economies, you can have startups, you can have funding campaigns, you can execute computer code, you can have ecosystems of computer applications, and yada, yada, yada. Just from this basic principle that everyone can add stuff to it. Once it's added, it's there. And that's literally it. Okay, of course. Now we're going to start introducing ourselves into the bells and whistles of blockchain, and we're going to see how can we actually make this weird example that just showed you a bit more practical. Because why would you have a blockchain where everyone can just add random data to it? If it's random data, why would this be useful to anyone else? And why wouldn't anyone just spam it with lots of data? So let's actually add some extra stuff to it. Before that, let's just do another example of what I just presented, but I guess a slightly more real world one. So if you go to a restaurant, they've got a guest book, right? But if you write a bad review on the guest book, the owner of the restaurant can always just come by and just tear the page apart. So not pretty nice. So kind of pretty centralized, right? The owner decides, what stays in the guest book and what not, because there's one guest book there. What if, however, every restaurant person brings their own copy of a guest book? Okay, and then let's assume that everyone goes to the restaurant with a blank guest book. And whenever someone wants to write something to the guest book, they write it on their own guest book, and then they scream, "Hey guys, I wrote this." And everyone else will be like, "Okay," and they're gonna write the same thing on their guest book. So essentially, again, we have everyone still has the same copy of the guest book, and now the owner can't just can't remove a bad review, or can't just tamper with anything really. And yeah, that's good. So let's summarize. Let's see what are the basic guarantees that we can actually see from these quite wild examples. So first of all, it's fairness, or more precisely, inclusivity. So what does that mean? Anyone in this anyone who participates in, who uses the blockchain, is equal. Everyone has the same rights, and everyone can do the same actions. In my example, everyone can add data to it. That's it. But everyone can do that, and that's key. Like, you don't have a hierarchy of people. Second, because this blockchain is copied around everywhere, everyone can see it. Everyone can read it, and everyone can see who did what when. And again, key. And that's with a lot of trust, because if something is in the blockchain, then the only way that this would have happened is if you had this whole synchronization thing happening before it, which adds security. And again, this is unchangeable with an asterisk. So nobody can technically change the blockchain, meaning if something happened, if something was added to it, that's it. And that's where it's security coming from. Of course, it's not all black and white, but that's generally what blockchains are aiming for. Okay, lots of wild examples. Now let's have a bit more practical ones. Let's say we have 4 computers now, and let's say we're trying to create a voting machine, or let's say we're trying to run an election. We want to make it fair, because some people have lots of money, and maybe they can sway the election by bribing people who count the votes or things like that. We don't really want any of that. So what are we doing? We're doing a blockchain. So we have 4 computers. Initially, again, the 4 computers have the same copy of the blockchain, which, let's say for now, it's nothing. Like, for now, the blockchain doesn't contain anything, let's say. But let's add some rules. So we don't just want people to be randomly adding data to the blockchain. We actually want only specific data to be added to the blockchain, and with some rules. Okay, so we're going to be defining a data structure that says the only thing that can be added to the blockchain is something that's structured like a vote, for example. So, this is a voting blockchain only. So what is a vote? A vote says that I am Jack, or I'm Bob, and I vote for Jack, for example. That's it. Like, it has some structure, and it has a particular meaning. Okay, and that's a vote, for example. Okay, and we would also like to make these votes verifiable. What does that mean? Well, we want to make sure that only Bob can actually submit a vote. So we want to make sure that we want to have some identity, so some way that people can actually authenticate themselves, because otherwise anyone can just impersonate Bob. So let's imagine that Bob has an account, and everyone else who's voting has an account, and they can to that account and prove that they are who they are, and include that proof as some bit of information inside the vote, inside this green thing in the middle. Okay, in some way they're sending a proof of who they are. In more technical terms, that's asymmetric cryptography. So Bob has a public-private key pair, and he's signing the message of what he's trying to say, what he's trying to send with that private key, and everyone else can verify. But if you don't understand what I said, it's all right. Okay, so what I'm trying to say is everyone participating in the blockchain can verify if something actually came from Bob. And let's say our computers won't just mindlessly copy this and add it to the blockchain. They'll first run some checks through it. First of all, is this a real vote? Did it actually come from Bob? Is the vote well structured? Like, does he have a sender, a receiver, that kind of thing? And also, most importantly, has Bob already voted? Because we don't want to allow double voting. And every computer independently can answer these questions for themselves because of the way cryptography works to like verify the identity of Bob, and because every computer knows what's the expected structure of a vote, and because every computer has the same history of the blockchain, they can check if Bob already voted before. And let's say Bob didn't. So what they're going to do is all their checks are going to pass, and this transaction will just be added to everyone else's blockchain, and now Bob has voted. If Bob tries to vote again, his vote will be rejected and it will not be included in the blockchain. So what happened just now is we ran some pretty fair elections with some pretty strict guarantees here. So first of all, nobody can impersonate voters, nobody can vote twice, and also vote counting is very easy and very straightforward, because the blockchain is everywhere. So all you need to do is you just need to read all the votes which were added to the blockchain, and you can know who the winner is. So that's it, and it's beautiful. Now, of course, it has some downsides. For example, because now we assume that we know the identities of who's voting, so you kind of know who voted for what. But again, it's not perfect. But it kind of gives you a more practical example of how blockchain can be used to do something more meaningful for humans, right? And it gives you the direction in which I'm trying to move this talk, not from just mindlessly adding random data to the blockchain, but having some strict protocols, some strict requirements of what constitutes new data that can be added to the blockchain, what makes it valid, what are the restrictions, yada yada yada. And if you add a few more rules like that, you can actually have a currency, you can actually execute computer programs and lots of other things, and it's quite beautiful. So let's also address where's the block in the blockchain coming from, because so far I haven't really talked about it. Now, in the blockchain, we don't really process individual messages, or we call them transactions. So let's just use transaction from now. We don't process individual transactions one by one. So computers don't just take a look at one transaction and then they verify it and then they add it to the blockchain, then continue with the next transaction. Because you've got many transactions, not quite efficient. So what happens is that they're first packaged in blocks. So a block is just a collection of transactions. And then the block is being verified by everyone. And if it's valid, it's being added to the blockchain. You see where the chain's coming from? Yeah. Cool. So let's have our first short theory break, where we're going to take a look at a blockchain explorer. Now, I mentioned that blockchains are quite publicly visible. So therefore, a website that allows us to easily browse and view what's happening in a blockchain should exist. And that's exactly blockchain.com. So if you open blockchain.com, if you open a tab that says Explorer, that's a blockchain explorer. This particular website is for the Bitcoin blockchain, but basically every blockchain should have a blockchain explorer, a website where you can just see what's up. Okay, so let's see what's up with Bitcoin. Well, it's quite expensive, but apart from that, if we just scroll down slightly to the most important part, we're going to see latest blocks. These are the latest blocks which have been added to the blockchain. We can see that on average, they're about 10 minutes apart. Well, it really depends. But yeah, they're a few minutes apart in Bitcoin. And yeah, we can click on them. We can see what they contain. So I told you they contain transactions. And they also contain a bit more information that I'm not going to go into. But it's pretty fun. It's a pretty simple cryptography if you're into it. But if we scroll down a bit, we can see transactions. We can actually see every single transaction which was executed in Bitcoin a few minutes ago. And it's pretty cool. For example, let's just pick one transaction. Let's pick this one. We can click on it and we can see actually what happened. And we see a lot of details. But in Bitcoin, well, Bitcoin is a currency. So the only thing that you can do in Bitcoin is send money left and right. That's what it does. Okay, so sending money has a sender and a receiver and an amount. So we can see that here a bit. So we've got a sender here. Okay, I kind of picked a less good transaction to show you because this one is a bit more special. So I don't really want to explain it. But let's say, all these transactions are more complicated, but whatever. Let's say this one. So it has a sender, in this case 2 senders, but let's just say it's 1 sender, okay? Okay, and it has a receiver, or in this case 2 receivers, and that's it. You can see, this person sent that many Bitcoins to these people, and that's a transaction. Pretty cool. Now, take a look a bit more. There are lots of things which I'm not explaining here. Now, I'm going to give you 3 minutes to click on blockchain.com, just figure it out, or just take a coffee break if I've blown your head already. I really hope I'm not. But in any case, I'll take a look at your questions. There's a Slido where you can ask questions. You can find this on the Hack the North schedule page. Also send questions in whatever streaming platform you are using, and please interrupt me with as many questions as you can. It's beautiful. I really want to make sure you're understanding things. Otherwise, I'll stop sharing for 2 minutes, and then I'll be back. Hello. So how was it? I hope that you managed to click around some stuff. Maybe you saw a lot of details that look weird or something, or maybe you understood everything. And in which case, what are you doing here? But let us continue. We've got a few more quite interesting things to do. Let's talk about money here. And let's make a small transition as to what Bitcoin is and how does it actually work. So I started with the example of users, using applications and communicating to a server, which is pretty centralized. Same situation with the banking system, right? You're sending money, the bank controls the money supply, the inflation, bank controls what fees you're charged, bank controls you even have the right to use money to begin with. Pretty centralized. Some people don't like it. So what does Bitcoin do and crypto in general? Well, they just remove it. And apparently you can just send money directly to anyone else without going through anyone else. Sounds pretty cool. Let's take a look at what it actually is, okay? And it's actually decently simple. Now let's just imagine that we have a spreadsheet. Now this spreadsheet means nothing. It's just a spreadsheet, okay? And I just added some stuff to that spreadsheet. It has 3 columns, okay? So we've got people, their identities, so the way that we can identify them, and the way that in which they can prove themselves. So, with signatures and everything, if you've heard of it. And then we have a 3rd column that just includes some numbers. Again, this is not connected to any financial system. It's just some numbers on my spreadsheet. Cool. And now I'm trying to tell you that I can turn this into a currency and people will actually be willing to buy it. Now, let's see how does it actually work. and it's pretty funny. So let's take all the examples so far, and let's just assume that we have, again, 4 computers. Let's assume that in this case, the 4 computers know about my spreadsheet, and the 4 computers right now have the same copy of my spreadsheet. Okay, so all that information is somehow stored on these computers. Okay, cool. And I'm trying to build a currency. So let's say that I want to allow users who are in the spreadsheet to exchange numbers between one another. Let's call these numbers Dogecoins. And so if Bob has 15 Dogecoins, maybe he wants to send some Dogecoins to Jack. Okay, so let's say Bob wants to send some of my spreadsheet coins to Jack. And let's say this is a blockchain, so clearly we're making a transaction here. So we're encoding this idea, this intent, as something to be added to the blockchain. So in this case, our blockchain only allows money transactions. What does that mean? Well, something that has a sender, receiver, and an amount. And again, this is not any kind of bank transfers. This is just operations on my spreadsheet. Cool. So Bob sends such a transaction. He signs it, meaning he proves that he is the actual that this message that was just sent was actually sent by him. Okay. And let's say that we're writing this blockchain so that every computer now has to do some extra checks before they accept my transaction. Just like with the voting example, this time we're going to have some other checks. First of all, this transaction come from Bob. Okay, cool. Second of all, does Jack exist? So like does for example does the receiver exist? And third of all, if we go back and look at the spreadsheet, does Bob actually have enough money to send to Jack? So let's say Bob had 15 spreadsheet coins. So now that's probably enough. So their checks have passed, and everybody has copied this transaction to their local copy of the blockchain. And in addition to this, everybody goes to their own copy of the spreadsheet and they update it. So they subtract 5 from Bob and they add 5 to Jack. That's it. Go. And congratulations, we've got a currency. But why would that be a currency, you might ask? Because everybody can do it, right? Well, first of all, a very important thing about a currency is trust, right? You need to make sure that if you hold something, if you own some coins or something, you want to make sure they keep having value in the long term, right? They don't just die tomorrow or something, or right. And that's why people trust big and huge governments and big and huge banks, because through their authority and size, they kind of provide that trust that, hey, listen, we're not going to mess it up. Okay, just use our green dollar bills. Okay, very similar thing here, except you don't have to trust anyone, because again, with the blockchain stuff, nobody can remove these transactions, nobody can tamper with them, nobody can issue fake transactions. So effectively, the only way that Jack can receive some spreadsheet coins is by being able to by actually submitting a legit transaction. So you can't just fool with the system here. You can't just invent some spreadsheet coins out of nowhere and just give it to yourself or give it to someone. Like, the system doesn't allow this. And because the system is everywhere, hence in a blockchain, it kind of works. Okay, but why would anyone exchange money for my spreadsheet coins? Well, let's imagine this. If I have a startup, right, and my startup is so amazing, I've got a product that's super incredible. Like, you really want to use that product, but I'm only accepting payment in spreadsheet coins. What's going to happen? You're going to flock to the stock exchange or to the crypto exchange, and you're going to buy all the spreadsheet coins that you can find, right? And what's going to happen with that? Well, they're going to have dollar value, and now you're going to be willing to exchange your cute little green dollars for some of my nice fancy spreadsheet coins. And boom, you've got a market, you've got currency exchange going on, you've got everything that, not really everything, but many of the things that constitute a currency. Beautiful. I think there is a question. Okay, let me just take a look at the questions, first of all. Okay, so questions. So one of the questions was, why was that BTC transaction special? Of course, I kind of expected this. So yeah, when I was showing the demo, kind of didn't want to explain one transaction. Okay, so the thing with Bitcoin, and the reason why people might want to actually essentially mine Bitcoins, so the process of buying huge computers and huge video cards and mine it, is because this actually allows you to create blocks for Bitcoin. Creating blocks is a very difficult and very random process, and I'll explain it a bit later how that works. But essentially, through creating blocks, you also, if you manage to successfully create a block, you get some free Bitcoins in return, which are created out of inflation. So the Bitcoin protocol just has a rule that says, hey, if you win a block, we're going to create some Bitcoins especially for you. And they're brand new, so like nobody else has used them before. And this was one of these transactions. It didn't have a sender. Notice I didn't have a sender, which is why I didn't want to show it. You only had a receiver, because that was the transaction that meant that the person who managed to create this block now gets some shiny new Bitcoins. That's for this question. If you delete data from the blockchain, does it show in the synchronized history of everyone? Okay, no, and that's a security of blockchain. You can't delete data from it, right? Because in order to, you can only delete data from your own local copy of the blockchain. You can wipe it, you can do whatever you want with it. But if there are 100 million computers who hold the same copy of that blockchain, you can't really remove it, right? You would have to take control of these hundreds of millions of computers doing the same thing and then remove it from their hard drives, which is practically impossible. So that's why you can't really move stuff. And you can't really corrupt stuff. Well, you can in some more extreme cases, but definitely not easily. And that's the whole point of crypto. Another question. Are there any blockchain auditors that check the security of blockchain systems? Absolutely. There's a bunch of them. There's a whole field of security companies, security auditors that help developers writing blockchain software do that. I know one of them. I personally know one of them is called Chain Security. I think it's chainsecurity.com. They allow you to, they give you some tools. If you're writing Ethereum smart contracts, they give you some nice tools, and they've got some nice research papers to help you do it better, and they also can audit it for you. If all the computers shut down for 1 second, would everything be wiped? Well, what do you mean everything? Well, if they shut down forever, then yes. But would that happen? No. I mean, if the asteroid hit the Earth, would everything be wiped? Absolutely. Do we care about it? Nope. So yeah, cool. Let me just get back to stuff. But I'm very happy that we have questions here. Please keep it up. Like I really want to do more of this and less of my talking. Okay. So Bitcoin. So is everyone on page with the currency stuff here? Okay. Why is this a currency? Why would anyone want to buy my spreadsheet coins? Because I've got this amazing startup which is gonna like bomb the whole world and stuff in a good way. I mean. Cool. Okay, so let's start looking into some problems here. And let's start to actually see how can we solve them. Because so far it was all pretty and well, but blockchain is not that black and white. So first of all, the question I conveniently didn't address so far is, what do you do if you've got more than one computer proposing to add a transaction to the blockchain? Or a block, okay. Like you've got many computers fighting over, who's going to be the next one to add something to the blockchain. And that's a very big problem because everyone must be synchronized, meaning everyone must agree on what's the next thing to be added to the blockchain. Because if different people add different things to the blockchain, then the whole thing breaks apart and burns in flames, and that's not cool. Nobody wants that. So you need some way that everyone can just magically agree on whose proposal should be accepted. And that's a very, very tough question. In fact, I would claim it's not yet answered completely. Every solution so far that we have has pretty significant disadvantages from one way or another, either security, scalability, efficiency, yada, yada, yada. We don't have enough time to take a look into this, but I will nonetheless briefly introduce the topic. So a consensus protocol for a blockchain has to answer some pretty big questions. First of all, again, which proposal do you pick? You've got to pick one of them, right? And second of all, can anyone influence that decision? So if you've got a big corporation, a big bank, or a big country or something like a very powerful figure, can they do something to influence that decision so that you pick a particular person's proposal or not? Because if you influence, which transaction, which block next gets added to the blockchain, you already begin to break the whole trust and break the whole consensus, because the whole point being single people cannot influence things. Okay, so you don't want to influence here. And third of all, I said nothing can be removed from the blockchain. Technically, it can in some cases. Okay, but it becomes progressively more difficult the more time passes. But nonetheless, can something be removed from the blockchain, and what needs to happen in order for this to happen, right? Okay. So let's start addressing these. First of all, a blockchain. Let's actually introduce the at least my favorite abstraction of a blockchain. It's a 3-layer thing, right? First of all, you've got a bunch of computers. Okay, they're forming a peer-to-peer network. What does that mean? Well, you need networking, right? You need some security mechanisms. How can you prevent someone from flooding the network? Like if one computer just spams everyone else with messages, how can you prevent that from being abused? Let's say that many blockchains don't necessarily differ much in the networking aspect. There are many clever solutions in this area, and let's say it's one of the less it's one of the places where you don't really have much to innovate compared to everything else in the blockchain space. Second of all, you need the blockchain to have some practical utility. What does it actually do? Is it a currency? Does it provide some special service? Right. This is what I call an execution engine. In more computer science terms, it means what kind of transactions can be sent. Okay, like is it money? Is it whatever else it means? What do these transactions mean? Why would someone use them? And in computer science terms, what are the particular rules that must be followed in the blockchain? So what constitutes a valid transaction? Okay, what constitutes whatever other requirements you might have in your blockchain? All of these checks in my examples for the voting system and for the spreadsheet coins, all these logical checks before you accept a transaction fall into this category. So that's the actual usefulness of the blockchain. Okay, and third, consensus. Right? How do you answer the questions I just posted earlier? So let's take a look at that. So Bitcoin, let's just ignore networking for now. It's not that exciting. So Bitcoin, what does it allow you to do? Well, it allows you to have a balance in Bitcoins. And if you have a balance in Bitcoins, it allows you to send Bitcoins left and right to anyone else who has a Bitcoin account. That's basically it. Pretty simple. Kind of related to my spreadsheet coin analogy. What is it, consensus? Well, it's called proof of work. And this is where we've got the whole idea of Bitcoin mining. Let's actually try to introduce it, but very briefly, and it's all right if you don't get it. So let's say that with Bitcoin we're working with blocks. Okay, so let's say that because everyone is equal, everyone has the right to propose a block. Okay, what does that mean? Well, first of all, everyone who uses the blockchain network, they're sending transactions. I'm Jack and I want to issue a transaction. All these transactions, they're not added to the blockchain. They're just circulating around in some sort of magical pool, like some sort of pool in the sky, like just a pool that collects all the transactions which haven't been added to the blockchain yet. Okay, and then everyone in the blockchain who wants to can take a look at this pool, can just take some transactions from it, can create a block from these transactions, so a block holding these transactions, and then can send this block to everyone else and say, hey guys, please include this block to the blockchain, because if this block is included to the blockchain, they're going to get some Bitcoins, whoever creates it. Okay. So how do you select which block do you add to the blockchain? Which block is the next one? And the way that Bitcoin solves it is by making it impossibly difficult to actually create a valid block. Okay, so we have extra restrictions. What constitutes a valid block? So it's quite simple actually in Bitcoin's case. So you take a block. Again, it's some sort of data, right, that contains transactions. Again, data. If you take this block and you hash it, what's a hash? It's a cryptographic function. What is that? Well, it allows you to take any information as an input, literally any kind of information, and it produces, let's say, a 32-byte number, like a huge, gigantic, random 32-byte number. If you hash the same information many times, you're going to get the same number. But then that number is very random, which means that if you change even a tiny part of the input data, that number changes completely. Okay, and you can't really predict that number. Like, you don't really know what number you're going to get out of some input data before you hash it. Okay, these are some very, very important factors. What is that? Why would I say that? Well, if Bitcoin says this, a valid block is a block that if you hash it, it starts with 10 zeros. That's it, or like some number of zeros, for example. That's literally it. And in order for anyone in the world to actually create a block which gets hashed with so many zeros at the start, that's impossibly difficult, because, again, you don't know, when you hash a block, you don't know what number you're going to get. So you're going to keep trying to create a block, like keep trying to change the input data a bit, shuffle some things around, and then hash it. So you got to be hashing lots of stuff all the time until you just find a particular block that just happens to have 10 zeros at the start. And then you're like, a little way. And then you just go around the whole blockchain network and you send it to every computer that you can find and be like, hey, I found the block. That's how it works. That's what Bitcoin mining is. That's why GPUs are so frequently used with it, is because they happen to be very efficient with this kind of computation. And the reason why this works is that it's so unlikely that two people at the same time would create a block with 10 zeros. That, yeah, it's just super unlikely that if you are a computer in the blockchain and you just see a block that starts with 10 zeros, you just accept it. Like, this is the next block, that's it. And you move on. Okay, so this is how you select as a single computer. Like, every participant in the blockchain network does exactly the same thing. And it works. Because if you see a block with 10 that starts with 10 zeros, most likely that's the only one. So that most likely that's the block that everyone else already saw anyways. So most likely you would be synchronized with everyone else if you accept that block. And we keep on going. And of course, in order to reward the investment of people who actually invest all these computational resources to create blocks, we can give them some Bitcoins as an inflation reward. That's basically it. Cool. Again, if something wasn't clear here, please shoot me away questions. I'm going to stop in a few minutes. I'm going to introduce Ethereum, and then I'm going to stop in a few minutes to answer some questions. Cool. So what's Ethereum? Well, Ethereum takes the functionality of Bitcoin, basically a currency, but takes it to a completely whole new level. It also allows you to write programs for it and to upload this code, this program, inside the blockchain. So you don't just store money there, you also store programs there. And once this program is on a blockchain, it can be executed on the blockchain, meaning it can function, it can provide some services on the blockchain itself. And just like currency, it can be trusted because this program is kind of executed everywhere on the blockchain. It's verified, all these stuff. I'm not going to get into details, but basically, if you upload a program to the Ethereum blockchain, nobody can change the way this program works. Nobody can tamper with its execution. It's just completely trusted. Like, this is where in the blockchain space we have this saying, code is the law. That's what it's coming from. Okay, so let's take a look at Ethereum. What does it do? Well, the only big difference from Bitcoin is the execution engine, right? It has the same networking and roughly the same consensus mechanism. So Ethereum allows you to have these programs. That's it. And it still uses proof of work, which has the same advantages and disadvantages. Proof of work is one of the most secure ways of having a blockchain consensus that we've found so far. Yet it's also one of the slowest, most environmentally unfriendly, and most unscalable ways that you can run a blockchain. Because of the way things work, like you need huge computers to do this, to mine. So technically speaking, the power consumption of Bitcoin is more than what most countries in the world are using, as a side note. But it is very secure. Okay, so for Ethereum, let's just take a look at a blockchain explorer there. And I just want to point out, so this is called etherscan.io, or if you just Google Ethereum Blockchain Explorer, you're gonna find exactly the same thing. I don't want to say Google, I want to say DuckDuckGo. If anyone knows what that's great. Okay, so again, just like with Bitcoin, we've got a bunch of stuff like in blocks. Again, okay, blocks, cool. Let's take a look at this block. What does it do? Well, it has 308 transactions. That's quite a lot. Let's take a look at them. Okay, there's lots of stuff. Let's take a look at this transaction. Okay, let me see why is that. Well, because it has a sender, and that sender is a person. Just like with Bitcoin, people have these identifiers in the blockchain. Amazing. In this case, the receiver is actually a contract, which is the way of saying a program. So this person is actually sending a transaction to a program, not to a person. Okay, and they're sending 0 money. So this transaction actually doesn't include any money because it actually executes the program by itself. It calls a particular function of that program, and this does something. In fact, we can just take a look at that program. What does it do? It's a contract. And we can see lots of people are using it. Lots of people. And fun fact, this is actually a program that it itself defines a cryptocurrency. So you got Ethereum, and then everyone can create a cryptocurrency inside Ethereum. And this one is a very special one. It's called Usd Coin. And I'm not going to go into the details of what is it, but basically you can have lots of weird stuff, and you can even take a look at the code here. Literally, that's the code of the program. It's not too big. It's 300 lines, and most of it is just some comments, right? It's actually very simple. It's impossibly simple. If you spend some hours, you're gonna completely understand this like fully. And I can read this because it's on a blockchain, so everything must be public. Okay, I'm gonna give you a few minutes now to click around etherscan.io, and I think we'll finish just about on time so far. So I'm going to give you 2-3 minutes, and in the meantime, I'll use that time to answer questions if you've got any. Oh, yes, we do. Holy bananas. Okay. I just filtered through the very helpful responses of my workshop helper. Shout out to Marcus. He's the behind the scenes tech guy who's helping me out with some of these questions. Yeah, I'm gonna have to only select a few particular questions, but I'll just skip the ones which Marcus already addressed. So there are different types of blockchains, absolutely, and we just presented two, right? Bitcoin on one thing which allows you to send money around, and Ethereum which allows you to create very complicated things. Again, quite simple as an infrastructure and as a mechanism, but it just has outstanding applications. It's all about what I called in the presentation the execution engine. What are the rules? So what kind of transactions can you send? What does the blockchain data mean, right? What can you do with it, practically speaking, as a human? What problem does it solve in your life? Do proof of work and proof of stake essentially do the same thing? Nope. Well, both of these are names of consensus algorithms, and I already presented proof of work because that's basically the easiest consensus algorithm to present. But no, proof of stake is a very different consensus algorithm which doesn't use mining, which doesn't actually use calculation, which uses some more clever algorithms in which you can select a block from everything else, not really based on computational power, which is what proof of work does, but based on more economical factors. Take a look into it, but I don't have the time to address it fully. Essentially, the general consensus is that proof of stake is generally less reliable than proof of work, but it's way more scalable. It's way more environmentally friendly because it just can do more transactions at the time. But it's slightly more centralized, meaning it takes less power to mess with the blockchain and to ruin it. What's the purpose? That's a nice question. What's the purpose of making it difficult to find a block? Well, if it was easy to find a block, everybody would do it. Okay, and if everybody could create a valid block, then you reach the consensus problem. Which block do you choose next in the chain, right? Everyone, because you don't have a centralized person that says this is the next block, right? You've got a bunch of independent computers in a network who are trying to just somehow independently decide which is the next block, and then they add it to their local copy of the blockchain, because if they don't do that, they are out of sync, right? They just lose the game. So in order to so basically, if you're a computer in the blockchain and if you see a block that's valid, you should be very confident this is the only valid block that exists. And the way that we can guarantee this is by making it really damn difficult for you to find a block. So another question: you can store programs in blockchain. Can those be sold like Bitcoin? So actually, interesting idea. Right now, Ethereum, I don't think Ethereum allows you to do this by default. Well, you just upload a program, and that program by itself might have some mechanisms that says, my owner is that person, for example. And that program by itself may have some mechanisms that says, hey, if you give some money to a particular person, you're going to become my owner. Whatever my owner means in this context. So yeah, you can do it because it's a program, and programs have data, programs have functions, programs can do whatever they want. You're completely free in implementing it, whatever, in whichever way you want to. So you can implement all kinds of crazy mechanisms. So another question, what does mining crypto mean exactly? What are you mining? Well, by mining, I meant creating a block, right? And creating a block, where I mentioned about how impossibly difficult it is to actually do that, because you have to make a block, hash it, until you find the right hash. And that's just very difficult, and you have to repeat it a billion times. And it's called mining because you just have to grind all the time. You mean your computer has to grind. Okay, so another question: if you create a crypto in the Ether blockchain, is the value of the crypto tied to the value of Ether? So the Ether is the crypto. There is nothing different here. If you look back at my spreadsheet example, I don't have currency. I don't have money. I have nothing. I've got just this spreadsheet with these numbers, and that's it. But people are looking to own these spreadsheet coins because they have practical utility for them. Okay, and it's the same case with Ether. The Ether is the crypto. So another question, nice one. Just how Ether is coming out with Ether 2.0, could BTC do the same? So could BTC technically do the same to consume less energy? Now, that's a very interesting thing, and it opens a very big topic that I haven't really covered yet, which is the idea of blockchains actually evolving. So I said that blockchains is something that everyone just uses the same logic, the same rules, and everyone just works in tandem with them. But technically speaking, if you can convince everyone that they should change the rules of the game, that the way Ether works or the way Bitcoin works should be changed a bit. If you convince everyone in the blockchain network to do that, and if they change it, then technically you have upgraded the cryptocurrency to some new functionality. And that's happening pretty regularly with Ether. They're introducing some new features and some new stuff, and they're actually moving to proof of stake right now. They've been doing that for the last 4 years, so I don't really know when that's going to happen. But what that means is that they're going to be consuming less energy if that happens. Could BTC do the same? Well, it really depends if the people within the Bitcoin network would be willing to accept such a change. And I would say no. I'm quite skeptical about this because the people holding Bitcoin and people actually using Bitcoin have a slightly different mindset from those on Ethereum. And it's quite interesting. I can share some articles later about this, but technically, no, I don't think so, because generally, many of the people holding Bitcoin really value the fact that it's so secure. If you move to proof of stake, it's not going to be that secure. Is the workshop recorded? Yes, you can replay it on YouTube Live if you want to, but I'm not sure how long is it going to stay up there for. Another question: why does the blockchain verify there aren't any duplicate hashes? Could you please reword that a bit? I'm not sure what you mean by duplicate hashes, because one of the very key properties of a hashing function is that you can never ever find two different pieces of data which hash to the same number. Okay, so this must be impossibly difficult, meaning you can't really have duplicate hashes, or if you do, you're gonna break so many things in the world. You're gonna break literally how the internet works. You're gonna break the security systems of literally everything if you manage to find a duplicate hash. So go for it. Otherwise, we're literally over time right now. So let me just very briefly continue. Don't worry, we have very few things left. So okay, Etherscan. Okay. So we're basically on the last slide. So I'm gonna leave this website for you to click around because we're out of time. It's ethstats.net. It's very cool. It's very nerdy. It just shows you some live parameters, live data from the Ethereum from the Ethereum blockchain. You can just see lots of cool stuff, and it looks fancy. Basically, that's why I put it up here. And it's also very interesting because every one of these things is very, very interesting to understand how they work and why do these things move, and everything around the dynamics are pretty cool. But anyways, that's the last slide, and I would like to end off that blockchain is, and referring to the person who asked, is there only one blockchain? Absolutely not. Blockchain is almost an infinite field at this point. Literally everyone is trying to create a better blockchain. There are so many projects out there with gigantic funding budgets. And many of them are trying to solve the same consensus problem. How can you find a consensus that's both fast, scalable, reliable, and secure? That's super difficult, actually. Many of these projects tend to either compromise security for scalability or vice versa. Nonetheless, it's very, very interesting to see what they did. How did they replace proof of work with? And also, what kind of crazy stuff are they doing? Like, it's not just Bitcoin or Ethereum. We've got lots of other meta level stuff happening here, like blockchains within blockchains within blockchains and that kind of stuff. And yeah, so these are only some of the older projects right now. There's so many other ones, so it could be completely inviolable. Otherwise, please take a look at the Slido link that's posted. Should be posted right now or very soon. That's going to be a feedback poll over there at the end of the workshop. Now, I'll be super grateful if you fill that in. I really want you to tell me everything that worked, but most importantly, everything that didn't work in this workshop, right? I want to know what you liked because, well, I enjoy teaching, right? But I want to make sure I do it well. And the problem with doing it online is that I literally have no feedback. I'm just talking about in front of this computer, like here it's almost midnight in Europe. And yeah, it's very, very, very difficult for me to get feedback. So if you could just fill that in with whatever thoughts you have inside, that's going to be super amazing. Take a look at the link in the chat somewhere. Otherwise, thank you a lot for listening. You can contact me here. And yeah, I also write poems as a side hustle. So if your head blew up with 200 blockchain, maybe you can read some pretty pessimistic stuff over there. Otherwise, thank you a lot for watching this. I will just take a look. I'll just stick around in case there are any other blockchains. So in case there are any other questions. I'm a bit too tired now. And yeah. The feedback poll should be activated, so you should be able to see it on the slide too. And I'll just watch for questions in case anyone else is having them, or otherwise, move to the next workshop or have some fun, take a cup of tea, whatever you like doing with your life. Okay, so someone asked, what would you recommend starting if I wanted to develop a blockchain, an application on blockchain? The only thing that I would recommend you to start is the blockchain is the blockchain workshop tomorrow. At the same time, I think 16 o'clock Canadian time tomorrow. We're going to be writing a bunch of smart contracts on Ethereum. It's going to be absolutely beautiful. Just go for it. Otherwise, take a look at the hack pack for this workshop. I've collected a bunch of amazing resources there. If you just want to actually understand in more details, how does Ethereum work? How does Bitcoin work? What are the alternative blockchains that are trying to solve the problems of Bitcoin or Ethereum, and vice versa? And the hack pack of the workshop for tomorrow as well. You can access both of them on the schedule page, even right now, if you want to. But if you have programming, some sort of basic programming background, do attend the workshop tomorrow. It's going to be amazing. Otherwise, where can I find a recording of the hack pack? So on the schedule page, so that's going to be my.hackthenorth.com/schedule. So I'm going to I'll paste the link somewhere. Yeah, thank you, Marcus. So yeah, you can find the YouTube live link there, and you should be able to view the recording after it's over. Okay, we've got 5 responses to the survey so far. I'm pretty sure more than 5 people watched me here, so if you're still around, don't be shy. Give me just a bit of feedback. And for the Hack the North peeps, it just took quite a bit of time and effort to organize, so it'd be amazing to figure out what we did right and what didn't work so well. All right, it seems like we're going to end the broadcast in a few seconds. So in this case, well, if you're still around, thank you a lot for watching. And fill the feedback form, check out the hackbacks, visit the workshop tomorrow, and have an outstanding rest of your day. And success if you're also competing for Hack North. Bye-bye.